Here we are at our example 1A from our 2.4 number 1 set of notes. But before we dive into this, let's go ahead and quickly talk about what is this slope-intercept form. Believe it or not, you've actually already seen this in the past. This is our most famed equation, y equals mx plus b. Of course, you guys have seen that last year. To help you guys kind of remember, I always say, I never understand why X decided to get married and then have a baby. Never understood that one. So if that helps you remember, by all means, go ahead and use it. If not, no worries. But again, slope-intercept form, here it is, y equals mx plus b. Our m is our slope. Our b is our y-intercept. And our x and y's are going to remain x and y because they work for a multitude of numbers. So again, x and y are coordinates that should work for many points. Many points. So again, though, that is slope-intercept form. Now, how we actually go ahead and use that. Looking at example 1a, we're asked to write an equation for the line given if we have the slope and a point. So right away, we're actually gone ahead and given our m value. We don't have to find him, which is kind of nice. And it contains at this point 1, 3. So with this point 1, 3, we know that we have some x and some y. Because again, this is just a coordinate point that does work for this particular line. So if I was to go ahead and graph this, just really fast, we have this point 1, 3. So 1 and then 3, which is right here. And then we have our slope, so up 2 over 1. And then up 2 again and over 1, creating that line. Now the idea here is we are given this point, and we are trying to figure out what is the equation of this green line that works for many different x's and y's. Now how we actually proceed with this is if we know what m is, and we know an x and a y, why not go ahead and throw him into our y equals mx plus b equation of a line. So when we do that, we end up with y equals mx plus b, because again, this is our slope-intercept form that we're going to go ahead and use. Throwing in our items, we end up with our y value. Here he is, 3, equals our m, we know it to be 2, times our x value, here he is, 1. And unfortunately, right now, though, we just don't know what our b is, our y-intercept. But we can very quickly find him out. On this side, we still have 3 equals 2 times 1, comes out to be 2, plus our y-intercept b. Going ahead and subtracting 2 from both sides, we see that b comes out to be equal to 1. Now, we are very, very close to being done. All we have to really do is rewrite the equation of our line. So we have, again, y equals mx plus b. And this should work for many, many different x and y coordinate points. Because again, we have just all these different x, y coordinate points, like here, here, and down here even. And as a result, we're going to go ahead and keep our y and our x just the way that they are. What we are going to go ahead and throw in, though, is our m and our y-intercept. So when we do that, we end up with y equals our slope, m, which is 2, keeping our x, plus our y-intercept here is, again, what we just found, b, which is 1. So again, this is our equation of the line that contains this point and has a slope of 2. And as you can see, it would work for then many different points. Again, though, that is our example 1A from our 2.4 number 1 set of notes.